All right, so we're gonna want to draw this structure, put these guys together. So I'm gonna start by just dropping this in here. And so here are the three amino acids, the aniline, the tryptophan, and the threonine. And how is it that I connect them up? What do I need to do? Yeah, so this and one of these hydrogens leaves as a water molecule on both of these. And so then I have a bond that's going to form between this carbon and that nitrogen. The orientation is kind of important because these are all chiral carbons, where the R group is. So if you flip the position of any of those things, it actually changes the stereochemistry. So you can't do that and have it be biologically correct. So no, I'm not going to ask you to, from memory, do this question. But if I gave you all of these, I would expect you to be able to put them together. What I am expecting you to remember is which of these are polar, which of these are non-polar, and which of these are basic, and which of these are acidic. So if I'm acidic or basic, I'm polar. So the polarity goes along with that. But that doesn't mean that anything that's polar is also acidic or basic, because the serine right there doesn't change the pH. It's not going to make it acidic or basic, but it would mix with water because it's got a hydroxyl group on it. So you might see something that looks like this on the test that doesn't have the background colors, just has everything listed. And you got to remember, by looking at the molecule, that side chain, is that going to make it polar or non-polar? That kind of deal. Or is that an acid, or is that a base? So then this would look like NH2CH, and then an N, and then that's a H, and then a H, and then a COOA, and then an N, and an H, and a C, and an H, and a COO, and then an OH. So the peptide chain, or the protein itself, is just going to continue like that over and over and over again. And then one end is going to have a nitrogen on it, and the other end is going to have a hydroxyl group on it. And the only thing that's going to change is my R group. So in this case, all I'm going to do is put a CH3 here. And in this case, all I'm going to do is do a CHOH and a CH3. And here, I got to figure out how to draw the whole funky tryptophan molecule, or side chain. So what would we call this thing right here? A peptide or a polypeptide. In this case, it'd specifically be a tripeptide, since there's 3 amino acids on it. What type of reaction caused these amino acids to bond to each other? What's the name of it? So what occurred here?
Dehydration synthesis.
Okay. What was created? What kind of bond was created? Okay. The specific type of bond is a peptide bond. But the peptide bond actually has another name for it too, from last exam. What is that there? That's an amide, right? That's how you make an amide, remember? That was an exam question. I need an amine, and there's an amine, and I need a carboxylic acid, and there's a carboxylic acid. So when I'm making a polypeptide, I'm really just making an amide over and over and over again through dehydration. So it's also a all right, what's the primary structure for a protein? Yeah, specific amino acid sequence. And the secondary structure?
The repeating stable bonds or the repeating uniform?
Shape of the backbone.
It's a uniform 3D structure. And it'll be and it's formed by So we're talking specifically about this part reacting with another part of that backbone. That's why the shape can be regular, because the polypeptide chain has that repeating over and over again, and I can get a nice regular shape, where I don't get a regular shape if I've got the R groups interacting with themselves. Okay. Huh. Really doesn't ask what the secondary and quaternary and tertiary structures are? That's weird. Okay, example of how it can act like a buffer. So if I add an H plus to it, where does this go? This would attach itself right there. And if I added a hydroxyl group to the solution, what would happen? A hydroxide? A hydrogen. And then make myself a water molecule. So in both instances, the hydrogen ion and the hydroxide ion disappeared from the solution. How can you separate out the amino acids? Okay, we've already destroyed it. All I have is a solution filled with amino acids. So how do I get them to separate out? Using the IP, which is the isoelectric point. So if I set the pH in the gel electrophoresis machine, so let's say I have these 4 amino acids sitting inside this solution, and I set the isoelectric point, which is pH. And so let's say that for this blue amino acid, the isoelectric point is 4.8, and that's a pH. So the solution here, let's say I've got this solution and it's at a pH of 4.8. So when I set a solution to an amino acid's isoelectric point, what does that do to the amino acid? Okay, so there's so this one right here has no charge. So I turn the voltage on, and what happens? These guys either move this direction or that direction, doesn't matter which direction they move, but they move. And the top one just completely stays put because it doesn't have a charge, so it's not going to be attracted to either a positive plate or a negative plate. So why would this one here, the red one, why would we say that one would move to the right? What must be going on with it? So what's the charge on this thing right here that I've got drawn? This guy's positive because this is neutral here, and there are 3 H's on this side, so this side of the molecule is positive. So what is this red amino acid going to do? It's going to go towards that negative. It's going to move to the right. And so that's what happens. I have the two, the amine side and the carboxylic acid side, but then I've also got this R group down here. And this R group could have an extra H on it, or it could be missing an H and basically be a hydroxyl group and be negative charge. And that's going to cause this thing to switch to go either to the right side or to the left side. So all I do is I set a pH and neutralize one of them and turn on the voltage, and everybody else is not neutral. So they either move to the left or the right, and they separate, the same thing separates itself out.
What's in that box?
Gel. I'm surprised you actually haven't seen it.
Biology 112, we do the lab.
I took that.
Really not a problem.